In this video, we shall derive the expectation and variance for the normal distribution as a continuous distribution. For more on this topic, you need to subscribe to this channel. Of course, the PDF, which is x, mu, and sigma square for the normal distribution, is given as 1 all over sigma square root of 2 pi exponential negative x minus mu raised to the power of 2 all over 2 sigma squared. So this is the PDF, that is f of x. So we shall be finding the expectation and the variance. For more on this topic, you need to subscribe to this channel. First, the expectation of x for the continuous distribution is given as the integral from negative infinity to infinity x multiplied by f of x dx. So this is the expectation of x, and this is the PDF. So we multiply it by this variable here. So it means we have negative infinity to infinity x multiplied by what we have here, 1 all over sigma square root of 2 pi say exponential negative 1 all over 2 x minus mu squared all over sigma squared then dx. This is our expected value of x. The next thing to do, we can say let c be equal to x minus mu all over sigma, which implies that x minus mu is equal to sigma t. So if we take dx, or we say x, it also implies that x is equal to mu plus sigma t. It then means that dx is equal to sigma dt. So this is called change of variable techniques. The next thing to do is to impute what we have here, x is equal to this, and the x will now come to this. We impute the whole of that into this. It then means that our expected value of x will be equal to, we have the integral of the integral from negative infinity to infinity. Our x, which is this, our x is equal to this. So we have mu plus sigma t. We also have multiplied by our exponential multiplied by 1 all over sigma square root of 2 pi exponential negative 1 all over 2. Then we have the whole of this as t squared. We have our dx to be this, so we have this dt. Of course, we can bring this out. We can also bring this out to this place to give us sigma all over. We bring the whole of this sigma into 2 pi integral negative infinity to infinity. Now we are left with mu plus sigma t exponential negative 1 all over 2 t squared dt. So this is what we are left with. Of course, this will cancel this to give us, now we have 1 all over square root of 2 pi into negative infinity to infinity. This will multiply the whole of this to give us mu exponential negative 1 all over 2t squared. We are also multiplying this by this, which is plus sigma t exponential negative 1 all over t squared, then dt. Dt is acting on all of this, so we can separate this to give us mu into the integral of negative infinity to infinity 1 all over square root of 2 pi exponential minus 1 all over 2 t squared dt plus the integral negative infinity to infinity sigma t all over square root of 2 pi exponential negative 1 all over 2 t squared dt. Of course, this is now our expected value of x. So we've succeeded in separating the whole of this. Now, we should note that the whole of this is equal to 1, while the whole of this is equal to 0. It then means that our expected value of x will be equal to mu multiplied by 1 plus 0. It then means that mu is our expected value of x. So we have our expected value of x here to be mu, because this is 1, this is 0. So mu multiplied by 1 plus 0 is equal to mu. The next thing to do is for we to look for the variance. Since we have found the expected value of x, so we will move over to this other side of the board to find the variance of the normal distribution for a continuous type. So we come here. Of course, we should recall that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. We should know that the expected value of x is equal to this. Now, we have to find the expected value of x squared, so that we now combine it to get our variance. So we have the expected value of x squared for the continuous distribution is equal to the integral from negative infinity to infinity x raised to the power of 2 multiplied by f of x dx. Of course, this is the PDF. F of x here is the PDF. The next thing to do is to impute the PDF into this, which is equal to the integral from negative infinity to infinity x squared multiplied by 1 all over sigma square root of 2 pi exponential negative 1 all over 2 x minus mu squared all over sigma squared dx. So this is our expected value of x squared. Of course, we can bring this out if we wish to give us 1 all over sigma square root of 2 pi the integral of x squared exponential negative 1 all over 2 x minus mu squared all over sigma squared dx. So this is our expected value of x squared. So the next thing to do is to use the change of variable techniques using change of variable techniques. Using change of variable techniques, we move over to this other side. We move over to this side. So moving over to this side, we said let p be equal to x minus mu all over sigma, which implies that since you are using the change of variable techniques, it implies that x minus mu is equal to sigma t, which also implies that x is equal to mu plus sigma t, and the x is equal to sigma dt. So this is what we have if we use the change of variable techniques as I have written it down here. So the next thing to do is to increase the whole of this into the expected value of x. If we do that, we'll get the expected value of x squared to be equal to, now we have 1 all over sigma square root of 2 pi integral from negative infinity to infinity. Now we have our x to be the whole of this. So we write mu plus sigma t squared because of this square here. Now the whole of this now becomes t multiplied by the exponential 1 all over 2 t squared. And we have the x here. The x will now turn to sigma dt. So we have sigma dt. Of course, this sigma can cancel this. That means we'll have it as sigma all over sigma 2 pi, the integral from negative infinity to infinity. We can also expand this to give us, from quadratic equation, we have that mu square plus 2 mu sigma t plus sigma squared t squared into exponential negative 1 all over 2 t squared dt. So this will cancel this. The next thing to do, we now bring the whole of this together. Of course, this is our expected value of f squared. So I'll delete this. Already we know that the expected value of x is mu. So I'll delete that. So we have that our expected value of x squared will be equal to 1 all over square root of 2 pi the integral from negative infinity to infinity. We have the whole of this. Now we can multiply this by everything here to give us mu squared exponential negative 1 all over 2 t squared plus 2 mu sigma t exponential negative 1 all over 2 t squared plus sigma squared t squared exponential negative 1 all over 2 t squared, then dt. The next thing is to use the whole of this and put here. So we have this as this multiplied by this to give us mu separately. The integral from negative infinity to infinity, we have 1 all over square root of 2 pi exponential negative 1 all over 2 t dt plus we have this as the integral of negative infinity to infinity. We have 2 mu sigma t all over square root of 2 pi. Now next we are using this to multiply this to give us this exponential negative 1 all over 2 t squared dt plus, in this case we bring out squared sigma squared. Now we have this multiplied by this. We have the integral from negative infinity to infinity. We have t squared all over square root of 2 pi exponential negative 1 all over 2 t squared, then dt. That is it. So we have it as our expected value of x squared. Of course, the whole of this is equal to 1. The whole of this is equal to 0, and the whole of this is equal to 1. So we have sigma squared multiplied by 1, mu squared multiplied by 1. So we move over to this other side to complete this. We'll delete this, we'll rewrite it back. So it then means that our expected value of x squared will be equal to mu multiplied by 1, mu squared multiplied by 1 plus, here we have 0, plus, here we have sigma squared multiplied by 1, sigma squared multiplied by 1. So we have our expected value of x squared to be equal to mu squared plus sigma squared. Of course, we know that the variance of x is equal to the expected value of x squared minus the expected value of x all squared. And we have this to be mu squared plus sigma squared minus, we have our expected value of x, which was written here to be mu. Because of this, it turns to mu squared. So of course, our variance of x will be equal to mu squared plus sigma squared minus mu squared. So this will cancel this. It then means that This is our variance of x. It then means that our variance of x is equal to sigma square. So we have the variance of x to be equal to sigma square, and we also obtain that the expected value of x is equal to mu. So this is how to obtain the expectation and variance for the continuous case of a normal distribution. So if you go through these processes, it will be very easy for you to get the expectation and variance of the normal distribution. For more on this topic, you need to subscribe to this channel.